Okay, so normally we start by looking at the calendar, like the schedule, to figure out what's coming and where we're headed and all that. But it turns out that the internet on the two computers I've used this morning at GCC is out. And so I do not have access to the documents that I normally grab because they're on some server that doesn't live in this room. So we'll just say that we have 1 day of new material today, one more day of new material Monday, and that's it for new material for this semester. We've got 6-2 here, and then 6-3 is on Monday. Next week is going to be a little bit strange. Friday's our makeup day. We can talk more about it on Monday. Okay? Am I saying that right? Is Friday the makeup day? Wednesday's the makeup day. See, I'm powerless without my calendar. Yeah, so Wednesday is the makeup day. We can talk more on Monday. Let's start with the objective here. Caroline. Okay, do you guys remember we talked about negative exponents really a while ago? And our basic idea was that this negative exponent was like a baby, and if the baby was on the floor, it wanted to be picked up in your arms, and if the baby was in your arms, it wanted to be put down on the floor. So anytime we had negative exponents, we needed to move the thing. Negative exponents indicate movement. Most important thing for today. If you see a negative exponent, in order to make it positive, you're just going to move the whole thing. So we're going to do 4 examples here together, and then you guys will do the group work. So first thing I'm going to do with each of these is start by drawing a blank fraction line. Almost all of them are going to be fractions, so I'm just getting my skeleton up there. Okay, first thing I see is a 2. Does that 2 have a negative exponent? No, so there's no reason to move the 2. The 2 stays exactly where it is. If you wanted to, you could put an over 1 just to convince yourself that that 2 is where? The 2 is on top. I'm not going to write the over 1. I'm not going to ask you to, but the 2 has no reason to move. Does the 3 have a negative exponent? Yes, so the 3 moves. Where is the 3 currently? It's currently on top. So it moves to the bottom, and when it moves to the bottom, what does it become? 3 to the positive 2. So that's the most important thing for today, is moving if you see a negative exponent. Now, if it's numerical, I'm going to ask you to maybe write it out, right? That's 2 over 9. But that's not the important thing for today. The important thing is if it's a negative exponent, you move it. Let's take a look at number 2. Start with a big blank fraction line. And we're just going to go term by term. Does this first 2 in the top left have a negative? Yes, so it moves. Where does it go? It goes to the bottom and becomes 2 to the positive 2. I'm just going to put a little check mark to indicate which ones we've done. Next one is a 5. Does it have a negative exponent? No. So does it move? No. So where do we put it? On top. Stays on top. Okay, someone other than Olivia. Does the 4 have a negative exponent? Yes, it does. So we move it to where? To the bottom. And it becomes 4 to the first, positive 1. And now I'm going to put a symbol in between the 2 squared and the 4. What symbol is it? It's multiplication. It's all multiplication. So if you need to put symbols in, it's a dot. Okay, we have taken care of all 3 of the things on top. Go ahead and take care of the 2 that are currently on the bottom. Either keep them where they are or move them. The 3 moves or stays. 3 stays. The 3 squared is still on the bottom. The 4 moves or stays. Moves upstairs as a 4 to the positive 2. Again, that's the most important thing in my opinion for today. We are going to clean this up and just write it as one single fraction. But the important thing is this idea of motion. Okay, you could do 4 squared is 16 and then multiply by 5, and that's 80, but it's easier to cancel things before we multiply. It's not mandatory, but it makes our life easier. So what do we see that cancels? You have 4 squared on top and 4 to the first on the bottom. So that single 4 cancels with one of those 4s upstairs. And that was so much fun. Let's do some more canceling. I see a 2 squared on the bottom. What is that? What is 2 squared? It's 4. And there's a 4 sitting upstairs waiting to go away. So all I have left is a 5 on top and a 3 squared on the bottom. So 5 over 9.
You didn't cancel out and you did it all.
It would. Let's do it just to convince you that this is better. All right, 5 times upstairs. We said 4 squared is 16. Down squared. So down is 2 squared is 4 times another 4 times 9. Okay, 5 times 16. How many of you guys just know that one in your head? Right, it's one of those that it's just like, it's just beyond our normal, like what we've memorized. So you got to do a little bit of work. It's 80. Divided by, downstairs, 4 times 4 is 16. But who here knows 16 times 9? Yeah, but it's not one of the, you got to do some work. And so we get 80 over 144, and then you got to do more work because 80 over 144 needs to be reduced. So for example, 2 goes into both of them, or 4 goes into both of them. Right? You got to do a lot of work to get this guy back down to where it belongs. And where it belongs is 5 over 9. But there's a lot of work in between that last equal sign. Okay, moving on to number 3. Have we talked about raising a number to the 0 power? 1 vote for no. Have we done that in this class? No. Okay. 3 times 4 to the 0. All right, so here is a fact. 4 to the 0 power is, any guesses? Could be 0. Other guesses? How much? Could be 4. That's natural. Other guesses? Turns out it's 1. Good question. Let's answer that question in a second. But assuming that 4 to the 0 is 1, then what's the answer to this problem? This is really 3 times. We said 4 to the 0 is 1. This one is 3.
Yeah, me too, because I saw.
Oh, yeah, it's number 3. Number 3. Had no idea where 9 came from. I judged you in that moment. I take it back now. All right, yes. Okay, so let's talk about this. 4 to the 0 is 1. I'll give you another strange fact. 5 to the 0, also 1. Anything to the 0 is 1. All right, so at least even in its strangeness, at least it's consistent. So let's talk about why that's true. Suppose that I gave you something like this. X to the 5th divided by x squared. If I write it out, 1, 2, 3, 4, 5 over 1, 2. How many are left when I cancel? Just 3 of them, which is really x cubed, yes? Okay, so now I'm going to change it slightly. This is one of these rules I'm going to ask you to memorize next semester if you have me for 096. I'm going to mention it now, but not ask you to memorize it at this point. But what's the shortcut? What can we do with the 5 and the 2 to get the answer? Subtract them, right? That gives us the 3. Okay, so if we're believing this idea of subtraction, then suppose that I give you this example. X to the 7 over x to the 7. If we subtract them, we get x to what power? 0, yes? That's what the little rule is that we'll memorize next semester. But forget that. What is x to the 7th divided by x to the 7th? It's 1. Right? It's the same number on top and bottom. So if I want to be able to subtract exponents, and it sure feels like that works, then I need to define anything to the 0 to be 1. Anything to the 0 is 1. It's just a fact put it in a red circle. That is something you need to be armed with for the final exam. Anything to the 0 is 1. Okay, last one here is number 5, which frankly looks simpler than some of the ones we've done up above. Start with a blank fraction. W to the negative 2 moves or stays? Moves. So we'll put it on the bottom as W to the 2nd power. W cubed moves or stays? That one stays. So we keep it on the bottom. What's the symbol in between? Is times. Okay, I've written everything that we had originally. Everything either moved or stayed. But I've got this fraction line that's blank on top. What do we have to put up there? We need to put a 1. And that's why this example is here. It's just to show you that, hey, even if everything is moved out of the top, you still have to write something on the top, even if there was nothing there before. 1 over. Okay, imagine writing this out. We're not going to, but imagine you got a couple of W's followed by 3 more W's, all multiplied. That's really W to the 5th. And the last thing I'll say about this example is that we were able to see that we had this blank that needed filled in with a placeholder, because what's the first thing I wrote down for this problem and for all the problems? Was a blank fraction line. And I think it's really easy. So 1 over is the right answer here, but I think it's really easy to look at this problem and say, okay, let's see, W goes on the bottom, so we'll put W squared down there, and W cubed is already there, and lose sight of the fact that it was in the bottom because you never wrote anything on top. And so I think it's a good idea, if you see these things with negative exponents, start every one of them with just a blank fraction line so you have 2 pieces to fill in. Okay, classwork starts on the next page. I'll put the flags out and raise them if I can help.